In this lesson, we're going to be reviewing substitution and looking at how we can tell if two expressions are equivalent. First, just a few reminders about algebra. Letters represent unknown values in maths, and so this x here, this is saying something plus 3 plus 5 times something plus a different something. Now this x and this x here, they have to have the same value. So if you know the value of one of them, you know the value of the other one. But the x and the y could have different values. They can actually also have the same value, but they don't have to. When you see a letter next to a number or two letters together, that means they're being multiplied, even though the multiplication sign's not written down. When you see a fraction, you can consider that like a divide. So this is y divided by 5. And we'll just need to quickly review our negative numbers and how we use them. So if I'm adding a negative, that's exactly the same as minusing. And if I am subtracting a negative, that's exactly the same as plussing. And if I multiply a negative by a positive, my answer will be negative, and it doesn't matter which one of the two numbers is negative. So 6 times negative 3 would have the same answer. If I multiply two negatives together, then that means they make a positive. And with division, it has the same rules as multiplication. So here I'm doing a positive divided by a negative, so my answer is going to be negative. And again, negative 6 divided by positive 3 would have the same result. It doesn't matter where the negative is, as long as there is only one of them. And finally, negative 6 divided by negative 3, if there's two negatives, then the answer is positive. The negatives cancel each other out. We should also just quickly review using BODMAS and showing our working one step at a time. So if I've got this expression here and I've got minuses and I've got brackets and times, I need to know what to do in what order. Remember, BODMAS is brackets, then you do your powers of, and then you've got division and multiplication. You can do those in either order, and then you go addition and subtraction. You can do those in either order. So here, because I've got these brackets, I'm going to do whatever's inside the brackets first. So I've got to work out 4 minus 1, and that's 3. And so the next line, I don't change the 7. I don't change the minus sign because I didn't use that. I don't change the times 5. I just change this bracket into a 3. And so on the next line, now I forget about that one. That's gone. I take a look at this one. What goes first, minus or times? And it's going to be the times. And remember, it's negative 3 times 5. The number has its sign in front of it there. So negative 3 times 5 is negative 15. So I just write down the 7 and then I write down negative 15. And then when I look at this, 7, now it's 7 minus 15. Remember, the minus signs are like negative signs or subtraction signs, depending on which way you're looking at it. And so here, when I went negative 3 times 5, I saw that as a negative sign. Now, because I'm looking at the whole thing, it's 7 take away 15, and so that is equal to negative 8. Let's get into it now just by quickly reviewing substitution. So when you're given the value of a letter, you can substitute it into the expression. So if I've got 4x plus 2, that's 4 times x plus 2. So if I tell you that x equals 3, then we know now it's 4 times 3 plus 2. And then you can evaluate it using BODMAS. So 4 times 3 would have to go first, that's 12, and now I can do the 12 plus 2, and that's 14. Now also just remember, you do need to be careful when substituting negatives, and so if I had 3 take away y and I told you the value of y is negative 4, then when I write it down, I don't write down 3 take away 4 because that would be ignoring either that sign or that sign. You need to put them both there. It's 3 take away negative 4, and then of course 3 take away negative 4, that would turn into a plus, and so the answer would be 7, 3 plus 4. Let's now see how we can tell if two expressions are equivalent. And so I've got my two expressions here. Now they're equivalent if they turn out to be worth exactly the same value. Kind of like two fractions. 1/2 is the same value as 3/6 because when I draw them, they take up exactly the same amount of area. And so we're going to see with expressions whether they may look different, but they're actually exactly the same value. They're worth the same amount. And so the way we do that is through substitution. And if you substitute any numbers into equivalent expressions, you'll always get the same answer, no matter what numbers you substitute in. So with these two here, I'm going to substitute in 1 for A and 2 for B. So let's start off with this expression. When I put in 1 for A and 2 for B, I get 1 take away 2, which is negative 1. And then when I move to this one and I substitute those same values in, you can't change the values, so 1 for A and 2 for B, and so that means it'll be 2 take away 1 because it's B take away A. We get 2 take away 1, which is 1. See how they've got different values there? That means that they are not equivalent. If they were equivalent, they would always get the same value. So we can say that these guys are not equivalent. When you're substituting your numbers in, it's generally best to pick different numbers, and you want to pick low whole numbers. You want to make it as easy as possible. So 1, 2, 0 is pretty good as well usually. Let's see what happens if I pick some different numbers for those two expressions. And so in this case, I'm actually going to make it the same number, which, like I said, you shouldn't do, partly because of what I'm about to show here. And so A minus B, 1 minus 1 is 0. And B minus A, that'll again be 1 minus 1, because they're both 1, is 0. Notice I've got the same value, but we already know these expressions aren't equivalent because you've got to always get the same value, no matter what numbers you're subbing in. And so when you do it, if you find you did get the same value, you need to do it again with different numbers just to check, because we've seen here it is possible to get the same value for each expression even though they're not equivalent, but you'll only do that with one special set of numbers. And so if you happen to get that straight away, you have to find out, are they actually equivalent, or did I get really lucky or unlucky, depending on your perspective, and just pick the only set of numbers that makes them have the same value. So if you get the same value, you've got to try a second set of numbers, which we'll see in the example. Let's get into some examples now. So we are going to substitute x equals 2 and y equals 5 into this expression right here. And so I'm just going to start by writing down the expression with the numbers already substituted in. So I'm going to write down 4 plus, and instead of x minus y, I'm going to go 2 minus 5, since they're the values that I know they are. So 2 take away 5 I have to do first because it's in the brackets. Brackets always go first. 2 take away 5 is negative 3. Now notice I keep the brackets there, and the reason being I haven't dealt with this squared yet. They're around the brackets, and so they're still part of the brackets. Now I've got to deal with this squared here, and so negative 3 squared, and it goes next because it's a power of. Negative 3 squared is negative 3 times negative 3, which is positive 9. And so I end up with 4 plus 9 there. And then 4 plus 9 is equal to 13, my final answer. Let's just do another one here where we've got to substitute, and in this one we're substituting a negative. And so when we write out the expression, we're just going to be careful to make sure that we include this minus sign and this negative in our expression there. And then we can do the 7 take away negative 3. Well, that's just a plus, so 7 plus 3 is equal to 10. Let's have a look at an example involving equivalence now. So we're going to see if these two expressions are actually exactly the same, even though they look different. We're going to see if they have the same value. And we've got to start by picking something to substitute in. Now there's only one letter, so we've only got to pick one value here. And I'm going to pick 0. 0 is usually my go-to. It's pretty easy, 0. There's very few times when you can't substitute it in. We'll see one in a moment. So when x equals 0, we're going to go 4 times 0 and then take away 2. Well, this is why 0 is great. 4 times 0 is nothing. So take away 2 is negative 2. And then let's try substituting it into this one here. And so negative 2, then in brackets, 2 times 0 plus 1, because it was negative 2 in brackets 2 times x. Now it's 2 times 0. Again, 2 times 0 is just nothing, which means it's just negative 2 times 1, because 2 times nothing is nothing, plus 1 is 1. So negative 2 times 1 is negative 2. Notice we got the same value there. So I could say, well, they're equivalent. Remember, I've got to try it again with a different number, just to make sure. And so now I'm going to say when x equals 1. Notice that I'm writing down what number I am substituting in. The question didn't tell me what numbers to substitute in. So it's not like these ones where I can just jump straight into the substitution. I have to say what number I'm using. And so when x equals 1, we've got, for the first expression up here, now we've got 4 times 1 minus 2, which is equal to 4 minus 2, which is 2. And then I'm going to try substituting it into this one here. So we get negative 2 times by, in brackets, 2 times 1 plus 1. Again, remember we've just made that x equal to 1 here. And so times 1 instead of 2x. And so 2 times 1 is 2. And then 2 plus 1, that's 3. And then negative 2 times 3 is equal to negative 6. We've just seen these guys are actually not equivalent. Even though it worked fine with 0, they're actually not the same value when I subbed in 1. Now, you might have done it a different way. If you were doing that question, you might have subbed in 1 first, and once you got to 2 and -6, you wouldn't bother trying a second number. As soon as you find something that doesn't work, you know they're not equivalent, and that's fine. Whereas if these did give the same number, then the same answer, I'd know that it'll always give the same answer, and I can say for sure these guys are equivalent. So these ones, though, they're not equivalent because they didn't get the same answer. Let's just have a quick look at a problem we can have when we substitute when there are fractions involved, particularly when what we're substituting is on the bottom. And so if I make x equals 0 here, then when I substitute it, I will end up with 3 over 0. Now, you can never have 0 on the bottom of a fraction. It's one of the things in mathematics. You just cannot work it out. So 3 divided by 0, if you did it on a calculator, it would give you an error. And so just be careful. You can't substitute 0 here, but you could try 1, 2, 3, any other whole number. If I looked at this one here and I tried substituting in 1 this time, when I did my substitution, I'd go 3 over 1 minus 1. Looks fine to start with, but then we realize, well, 1 minus 1 is 0. I'm going to end up exactly the same problem over here. And so when you're substituting, if the letter does actually appear on the bottom of a fraction, that's when you need to just be careful. If you end up with 0 on the bottom, you're going to have to toss that one out, and you have to try a different number to substitute in. Let's try a couple of practice questions now. Remember to pause the video. And there's our solution with a little bit of working here and quite a lot of working here. You might have picked different numbers to substitute in, but either way, if you substitute in x is 3, for example, your answer here would be different to what I've got. It wouldn't be 2 anymore, but it would match what you got when you substituted it into the other expression. So these two answers should match, and these two answers should also match. Let's go through those. For the first one, I had this expression here, 5x minus y, and I had to substitute in x equals 5 and y is -1. So I started by writing down the expression, but instead of an x, I wrote down a 5, and I put the times there because it's 5 times x. Don't need to write the times sign with a letter, but we do when it's a number. And then it was minus y, and since y is -1, I wrote down minus -1. And then I had to start working it out. Now, using BODMAS, I did 5 times 5 first, which is 25. And I know that if I minus a negative, then it becomes a plus. So I just changed that there. You're allowed to do that. That's fine. And then I went 25 plus 1 is 26. Now, if you wanted to, you could put a circle around that and make it a plus. Or you could have left it as minus minus here and then made it a plus. That's fine. As long as you worked out the 5 times 5 first, then you'd get the same answer. Now, for the second one, we're going to state whether or not these two expressions are equivalent. So over here, firstly, I started by substituting 0 in for the x, and over here, I started on this first equivalent up here, and I got the answer of 2 when I subbed in 0, because -6 times 0 is nothing, plus 2 is 2, obviously. And then on this second one here, for the second expression, when I subbed in 0, I did the -6 times 0 is again nothing, and then, well, there's just 2 left over because the -6 times 0 was nothing. I got the same answer, and so I thought, all right, well, I'm going to have to try it with another number as well then. So I picked 1 because it's a nice low whole number, and I substituted 1 in. This time I went -6 times 1 is -6, and then I could add the 2, got me to -4, and when I did it to this expression over here, the second one, I went -6 times 1 is -6, 2 take away 6 is -4. I got the same answer, which means they are equivalent. And if I had to substitute in x equals 2, the answers would have been different to -4, but they would have been the same as each other, still showing they were equivalent. It doesn't matter what number I substituted in for x, I'd always get the same two answers here when I substituted it into both expressions. That's why they're equivalent. Here are some more practice questions. If you need to have another go, remember to pause the video. And here are the solutions. On this first one, notice I did the 3 times -2 and the 4 by 1 just in one step because they were both multiplications. So you can do that. If you separated them out in different steps, that's fine, as long as you still got -2 as your answer. And of course on this one, because I picked 0 and they weren't the same, I didn't have to pick anything else. You might have picked a number where they actually turned out to be the same. When you tried the second number, you would have found it doesn't work though. So you'd still be able to work out they're not equivalent there. Remember to seek some extra help if you're still having trouble with those. And that is the end of the lesson.